Okay, so we have discussed 3 different solid figures. Let us discuss 2 more solid figures. The fourth one is sphere. Fourth one is sphere. A sphere is something like this. If we look the sphere, if we look at the sphere in 2D, in 2-dimensional, it will look like a circle. Okay. So this is a sphere. You know very well what is a sphere. It's like a football, and let us say the radius of this sphere is r. So the parameters, the formulae related to sphere, the first one is curved surface area. The curved surface area of a sphere is 4 pi r square. Okay. It's very difficult to calculate the area of the sphere. It's not it's like beyond your scope, because it includes some kind of calculus method. Calculus is a method which was discovered by Newton, and that you will study in class 11th if you take maths. Okay, or else just for class 10th you can remember this formula of curved surface of the sphere, that is 4 pi r square. The second formula related to sphere is total surface area. Now, previously we have seen that total surface area is known as curved surface area plus area of the top and the base. Okay? But if we consider sphere, we can see if I keep this sphere on a ground level, what I will observe is that this ground is basically tangent to the sphere at this point, like this. Okay, this ground level will touch the sphere only at a single point. Try to analyze this, try to understand this, try to imagine this. If I keep a football on the ground, it will touch only touch the ground only at a single point. Okay, only at this point. So the ground will be tangent to this sphere. So I will say that this sphere has the base area equal to 0, because the area of a single point is 0. Okay, so I will say that if I keep this sphere on a plane, it will occupy 0 square units of area on that plane. Okay, just remember what I am talking about is, if I keep this sphere on the ground, it will touch a single point on the ground. And if I tell you to calculate the base area of the sphere, it means I am telling you to calculate the area of this point. The area of this point is 0. Okay, that's why here we will going to have curved surface area, this total surface area equal to curved surface area only, and that is meant by that total surface area and curved surface area of a sphere are equal. Okay, there is no difference, because area of the base of the sphere is equal to 0, because this sphere do not have any base, like this. It is touching this ground only at a single point. The third parameter is volume. Volume is volume of a sphere. Again, as I have said, that it is difficult to determine the formulae of this sphere, because it requires calculus, which is a part of mathematics. Okay, part of mathematics, a calculus part, which is not in our course, it is beyond our scope. That's why again we will going to learn the formula as it is. So formula for volume for a sphere is 4 by 3 pi r cube. Okay, and if I talk about the base area, see, base area is not defined for the sphere, because sphere cannot have any base. It is touching the ground only at a single point. Okay, then the fifth one is hemisphere. Now what is a hemisphere? If I cut this sphere into 2 parts, then I will get 2 hemisphere. If I cut this sphere about its diameter, then this figure will be known as hemisphere. like this. This is a hemisphere. Since I have taken out this hemisphere from this sphere, the radius of this sphere is r, so I can take the radius of this hemisphere is also r. So this is a hemisphere of radius r. Now what we can see is, since I have cut this sphere into two parts, so the surface area will also be divided into two parts. So if I talk about the curved surface area of this hemisphere, of this part of the sphere, that is a hemisphere, the curved surface area of this hemisphere will be half of curved surface area of this sphere, that is 2 pi r square. Okay, just half of curved surface area of the sphere. The second thing is total surface area. Now you can see that sphere do not contain any base, but this hemisphere has a base. If I keep this hemisphere like this on a plane, then its base will occupy this much area. Okay, that is the area of this base. So I can say that in case of hemisphere, the total surface area will be equals to curved surface area plus area of the base. This is the base. So this is a circular base, radius is r, so I will say the area of this base will be pi r square. So in all I will get total surface area of this hemisphere as 3 pi r square. This is the total surface area of this hemisphere. The third thing, volume of this hemisphere. What will be the volume of this hemisphere? You can see this is a sphere. I have divided this sphere into two equal parts, so definitely the volume should also be divided into two equal parts. So if the volume of this sphere is 4 by 3 pi r cube, then the volume of this hemisphere will become 2 by 3 pi r cube. This will be the volume of this hemisphere. Then if I talk about the area of base of this hemisphere, area of base, then area of base will be the area that it occupy when kept on a plane. How much area will it occupy when I keep this hemisphere on a plane? This much area, the area of this base, this circle. This circle is of radius r, area of this part is pi r square. Okay, pi r square. Remember, the area of base is not defined for the sphere because it do not have any base. If I keep this on a plane surface, it will touch the surface only at a single point. Okay, that's why the sphere, or I can say the area of the base of the sphere is 0, and area of the base of a hemisphere is pi r square. So these are the common solid figures that you have studied in your 9th class, and this is just a quick review. We have just revised all the formulae that we have studied. Now coming to the topic that we need to study in 10th class. The first thing that we will going to study in this chapter is conversion of solids. We will start our discussion with conversion of solids. As I have said previously, conversion of solid means I am melting down a big iron ball and drawing it into wires, or making small ball bearings from that big iron ball. It means what I am doing is, if this is my iron ball and I am melting this iron ball and making small ball bearings like this, okay, like this, it means I am using the iron that is contained in this ball to make these ball bearings. Now the iron that is available to me from this ball, that iron can only be used to make this ball bearings. I cannot add extra iron into this. So the total iron that is used to make this ball will be equal to the total iron used to make this ball. If this ball is of wooden ball, then if I convert this wooden ball into small wooden balls, then I will say the total wood that is contained in this ball will be used only to make this small ball. That means the total wood inside this ball will be total wood used to make these balls. Or I can say in simple terms that material of this ball will be equal to material used to make these balls. Okay, the total material that I have, that material can only be used to make these balls. I cannot use extra iron, I cannot take any iron from it. Okay, I have to use this complete iron and convert this into small balls. तो हम कहेंगे कि जितना आयरन हमारे पास इस बॉल में है उतना ही आयरन हम इस बॉल बियरिंग्स को बनाने के लिए यूज कर सकते हैं. और आई विल से द वॉल्यूम ऑफ this ball, let us say the volume of this ball, this is ball 1 and these are balls, let us say these are n number of balls and balls of same size. Okay, so I will say volume of ball 1 will be equals to volume of n balls. ओके ऐसा मैंने क्यों कहा? बिकॉज जितना आयरन इस बॉल में है उतना ही आयरन तो मैं यूज कर सकता हूं इन बॉल्स बनाने के लिए. मैं कहीं से बाहर से और आयरन इसमें नहीं डालना चाह रहा. मैं क्या चाह रहा हूं? सिर्फ इतना ही आयरन यूज हो इन बॉल्स को बनाने के लिए. मतलब जितना वॉल्यूम इस बॉल का है, जितना वॉल्यूम इसमें आयरन का है, उतना ही वॉल्यूम यहां पर भी रहेगा. बिकॉज आयरन ना तो क्रिएट होगा और ना ही डिस्ट्रॉय हो सकेगा. ओके, एटम्स जो होते हैं, एटम्स मॉलिक्यूल्स जिसके बारे में हम पढ़ते हैं केमिस्ट्री में, दे कैन नॉट बी डिस्ट्रॉयड और दे कैन नॉट बी क्रिएटेड. ऐसा आपने पढ़ा है. ओके, कंजर्वेशन. सो कंजर्वेशन लॉ के अकॉर्डिंग जितना मास, जितना वॉल्यूम इस आयरन का है उतना ही वॉल्यूम इस आयरन का रहेगा. एक भी एटम ना तो बनेगा और ना ही डिस्ट्रॉय होगा. ओके, प्रैक्टिकली ऐसा होता है कि कुछ आयरन वेस्ट हो जाता है, कुछ पार्ट आयरन का वेस्ट हो जाता है. बट फॉर द कॉन्सेप्ट इफ आई टेक, देन द वॉल्यूम ऑफ दिस आयरन और द नंबर ऑफ एटम्स इन दिस आयरन, द वॉल्यूम ऑफ द एटम्स इन दिस आयरन विल बी कांस्टेंट. ओके, इट विल नॉट चेंज, विल बी इक्वल टू द वॉल्यूम ऑफ दिस आयरन और नंबर ऑफ एटम्स इन दिस आयरन. ओके, सो कॉन्सेप्ट ये कहता है कि अगर मैंने इस बड़े आयरन बॉल को मेल्ट करके छोटे बॉल बियरिंग्स बनाए तो वॉल्यूम दोनों ही केसेस में बराबर रहेगा. इट मींस इफ आई से कि इसका वॉल्यूम हम लेट अस अज्यूम V1 मान लेते हैं, इन सभी बॉल्स का वॉल्यूम हम लेट अस से V मान लेते हैं. एक बॉल का वॉल्यूम V है, सेकंड बॉल का भी V है, ऐसे करके अगर n बॉल्स हैं, n नंबर ऑफ बॉल्स हैं, सो टोटल वॉल्यूम कितना हुआ? टोटल वॉल्यूम हो गया n टाइम्स V. Okay, so mathematically I will say that these two balls are related as V1 is equals to n times V. This is the concept, this is the formula that we will going to use in conversion of solids. Okay, this is the only single formula that we will use in conversion of solids topic, because this complete topic is based on this single formula. इस एक फॉर्मूले से हम कन्वर्जन ऑफ सॉलिड्स पे बेस्ड किसी भी क्वेश्चन को बड़ी आसानी से सॉल्व कर सकते हैं. ओके, तो ये कन्वर्जन ऑफ सॉलिड्स है, इसे नोट कर लीजिए. आफ्टर दिस हम क्वेश्चन सॉल्व करके कुछ एग्जांपल्स लेते हैं, एग्जांपल्स के थ्रू समझते हैं कि कन्वर्जन ऑफ सॉलिड के क्वेश्चंस आखिर आते कैसे हैं, उनको सॉल्व कैसे करना है, अप्रोच क्या होनी चाहिए. ओके, सो फर्स्ट यू नोट दिस. Okay, so we have discussed the introductory part of this chapter. We have discussed what are different kinds of solids that are available, solid figures. We have calculated their areas, their volumes, their surface areas, their area of base and all other things. And we have also understood that what exactly is meant by conversion of solids. Conversion of solids, it means if one kind of solid is melted down and is made into different shape, its shape is changed. In that case, the total volume of the solid, that is total amount of whatever the material that is, it will not change. If I have 1 kg of an iron ball, then the total volume, the total mass of all the balls or all the shapes that are made from that 1 kg of iron ball has to be 1 kg, because mass will never get destroyed. Okay, mass destroy कभी भी नहीं होगा. So एक कॉन्सेप्ट जो हमें यहाँ से समझ में आता है, दैट कॉन्सेप्ट इज कि मास डिस्ट्रॉय नहीं होगा. द टोटल मास बिफोर द रीशेप एंड आफ्टर द रीशेपिंग इट विल बी कांस्टेंट. ओके, इवन द डेंसिटी ऑफ द मटेरियल विल ऑल्सो नॉट चेंज, बिकॉज आयरन की जो डेंसिटी होगी वही डेंसिटी उसकी पहले भी रहेगी और बाद में भी रहेगी, डेंसिटी चेंज नहीं होगी. हाँ, अगर हम कुछ केमिकल प्रोसेस लगा के, कुछ केमिकल मिला के उसकी डेंसिटी को कम करते हैं, देन इज अदर थिंग. What I am talking about is we will going to deal with just simple calculations with simple questions, that is the density of the material or the iron will not change. Okay, density change नहीं होगी. For example, आप clay use करते हैं, clay से आपने कुछ एक shape बनाया, let us say cone बनाया, फिर आपने उसी क्ले को रीशेप करके एक सिलेंडर बना दिया. सो हम देखेंगे कि जो वॉल्यूम कोन का है उतना ही वॉल्यूम उस सिलेंडर का होगा. ऐसा ऑटोमेटिकली एडजस्ट हो जाता है. ओके, हमें पता भी नहीं चलता कि ऐसा एडजस्टमेंट हो रहा है. सो बेस्ड ऑन दिस कॉन्सेप्ट ऑफ कन्वर्जन ऑफ सॉलिड्स, लेट अस सॉल्व सम क्वेश्चंस टू गेट अ बेटर अंडरस्टैंडिंग. लेट अस स्टार्ट विद द प्रैक्टिस शीट. वी विल सॉल्व question number 1 from the practice sheet. Question number 1 says 2 cubes each of volume 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. Okay, so the question is very simple, that there are 2 cubes and the volume of each cube is 64 centimeter cube. Okay, so there are 2 different cubes and these 2 cubes are joined end to end to form a cuboid. We need to determine the surface area of the resulting cuboid. Okay, for that let us first draw a diagram, because in this chapter the diagram is very very important. If you are able to draw, if you are able to visualize the diagram of any question, it will be very easy for you. This chapter will be very easy for you to understand. So let us draw the diagram. It says that there are 2 cubes. This is, let us say, the first cube. The volume of this cube is given as 64 centimeter cube, and there is one more cube which is similar to this cube, and this cube is this one. Okay, and the volume of this cube is also 64 centimeter cube. So if I join these 2 cubes, it will form a cuboid, and I need to calculate the volume, the surface area of the cuboid so formed. Okay, if I join these 2 cubes, how will these 2 cubes be joined? I will join them like this. Okay, this is one cube and another cube is joined to this cube in this manner. Like this. like this. I have joined the two cubes. This is the first cube, the green one, this is this cube, and this is the second cube, this one, and I have joined these two cubes and formed another shape. So this is a cuboid. I need to calculate the surface area of this cuboid. Now what is the requirement to calculate the surface area? The surface area of a cuboid is surface area. Now please remember, if I am saying that surface area means total surface area. If I say curved surface area, I will specifically speak about curved surface area. If it is just written the surface area, then I will say total surface area. So surface area of cuboid is what? It is 2 times L into B plus B into H plus H into L. This is the total surface area of a cuboid. So to calculate the surface area of this cuboid, I need B, I need H, I need L. So all these three parameters, the length of the cube, the breadth of the cube, this is the breadth, and the height of the cube, this is the height. These three parameters are required. So can I calculate these three parameters? Yes. I have these two cubes of same volume, 64. What is the volume of the cube? If I say that, let us assume the side of this cube is A, then volume of the cube is A cube, and this is given as 64. So use this identity, A cube is equal to 64, it implies A is equals to 4. So the side of this cube is 4 centimeters. The sides of this cubes are 4 centimeter long. So if I see the length of this cuboid, I can see the length of this cuboid is made up of 2 times A. This is A and this is A. So the length is equals to 2A. Okay. If I talk about the height of this cuboid, height is equal to A, because you can see this side of cuboid and this side of cuboid are same. Similarly, if I talk about the breadth of this cuboid, this B is equal to A. Okay. So surface area of this cuboid will be 2 times L is 2A. What is 2A? It will be equals to 2 into 4, that is 8. Okay. Then what is H? H will be equals to 4. And what is B? B is equals to again 4. The breadth of this cuboid is 4, height of this cuboid is 4, and the length of this cuboid is also it is 8. Okay, double of the side of this cube. So the surface area of this cuboid will be L into B. L is 8 into B is 2 plus B is 2 into height. Height is again 2, not 2, it's 4. Plus height is 4 and length is 8. So just calculate this value and you will get the final surface area of this cuboid. So it will be 2 times of 8 4s are 32 plus 16 plus 32, that is 2 times of 32 plus 32 is 64, 64 plus 16. So this will give you 2 times of, this will be 80, which is equals to 160 centimeter square. So this will be the total surface area or the surface area of this cuboid. And see how this cuboid is formed. It is formed by joining the two cubes by end to end. So this is one end of the cube, okay, one end of this cube, and this is the end of this cube, the second cube. And if I join these two sides, these two faces, it will become a cuboid. So you can see this is the common face of this cuboid. Okay. So this is how I need to solve the question in this chapter. In class 9, you have solved simple questions which are based on a simple cube, and you need to calculate its area, surface area, volume, or a simple cuboid. But here we have joined two different figures and we have converted these two figures into a single cube, and then we have calculated the surface area. Okay. So this is the solution for first question. you can see this question is very simple, it's very easy to solve. Let us solve second question. The second question of the practice sheet says a cone of height 24 centimeters and radius of base 6 centimeters is made up by molding clay. Okay. So there is a cone whose height is 24 centimeters and the radius of the base is 6 centimeters. It is made up of molding clay. What is molding clay? It's a kind of clay which can be molded into any shape. So using that clay I have made a cone. Further, a child reshapes the cone or the clay it in the form of a sphere. So the child made this clay from a cone to a sphere. Okay, it's reshaped. It is not saying that the child took a part of the clay and then made a sphere. What it says is that child simply reshapes the same clay which is used to make the cone into a sphere. Okay, find the radius of the sphere. So try to understand the question. It says that the clay, the material of the clay is used, let us say some x grams of clay we are using. So x grams of clay first is converted into a cone, and further the same x grams of clay is remolded into sphere. It means this solid cone is converted into a sphere. So what is the identity, what is the formula for conversion? That the volume of the material should remain constant. So in question number 2, what I have done is that, let us say this is a cone, and it says that the height of this cone is 24 centimeters. Okay, the height of this cone is 24 centimeters and the radius of base is 6 centimeters. And I have converted this cone into a sphere, and my task is to calculate the radius of this sphere. Let us say the radius is r. Okay, I have used the clay to make this cone of height 24 and base radius 6, and then I have reshaped the same clay into a sphere. It means the volume of the cone, the volume of material used to make the cone should be constant, and the volume of sphere, the volume of material used to make the sphere should be equal to the volume of the cone. Okay, so since it's a conversion process, what I can write is volume of clay used to make cone is equals to volume of clay used to make sphere. Okay, the volume of clay that is used to make the cone is equal to volume of clay that is used to make the sphere. So what is the volume of cone? The volume of cone or volume of clay used to make the cone is 1/3 pi into r, which is 6, square into h, which is 24. Okay, 1/3 pi r square h is the volume of this cone. What is r? It is 6. So 6 square into h, which is 24. So this is the volume of this cone, or I should say the volume of clay used to make this cone. Now what should be the volume of this clay which is used to make the sphere? It depends on the radius of the sphere. So I will say this is equal to volume of clay used to make this sphere. What should be the volume of the sphere? Volume of sphere is 4/3 pi r cube. Okay, where r is unknown. Why? Because r is the radius of the sphere that we do not know. I do not know whether if I use the clay of this cone and make the sphere of this cone, I do not know what kind of sphere, what how much bigger sphere will be formed, and that I can calculate using this formula. So let us solve this. You can see this 3 and 3 will get cancelled, this pi and pi will get cancelled, this will give you 4, 4 ones are 4, 4 6 are 24, and you will get 6 cube is equals to r cube, which implies r is equals to 6 centimeters. So the radius of the sphere that is formed using the clay of this cone will be equals to 6 centimeters, okay, 6 centimeters. Remember what we have done, we have converted one kind of solid figure into another. So the material that is inside this solid figure should be same as material inside that solid figure. So this is how you need to solve the second question. You can see it's very easy question, but don't be happy because the tougher questions are waiting for us. So this is the second one. Okay, first you note these two questions, then we will solve the third one.